This one is another interesting question. We have another gift hamper. Last time Santa gave us gifts. This time there is a gift hamper. It's got 147 pens, 441 pencils, and 784 chocolates. All of which are distributed. So nothing is kept back. How is it distributed? We'll come to what the question is asking a while later. We'll look at how is it distributed. If a student gets X pens, then all students get X pens. Okay, distributing it in such a way that if I give 5 pens to one student, then every student is going to get the same 5 pens. In this case, X pens. If a student gets Y pencils, then all of them get the same Y pencils. And so on. So if someone gets Z chocolates, then everyone is going to get the same Z chocolates. What we need to find out is the maximum number of students who can receive these gifts. Let's assign that the number of students, which is what we're trying to find out, to be n. Now, we have n students in the class. Each student gets X pens. Let's say there are 5 students in the class. Each one gets 7 pens. Then the number of pens distributed will be 5 into 7, which is equal to 35. In this case, n students, each one gets X pens. So n into x is going to be equal to 147. The number of students does not change, but we are giving more pencils because we have more pencils available with us. So n into y is going to be equal to 441. And n into z is going to be equal to 784. So we have framed equations for all these 3 scenarios. Now quickly, one thing that we realize, n and x are factors of 147, n and y are factors of 441, n and z are factors of 784. But n is a factor of 147, n is a factor of 441, and n is a factor of 784. It essentially means that n is a factor common to all these 3 numbers, 147, 441, and 784. So the number of students that we'll have to find out is nothing but the common factor. This is a realization that we have. But hold on, what is the question asking us to find out? It is not asking us to find out some number of students, because 1 is a common factor to all these 3 numbers. So I can clearly say 1 is the number of students. We'll have to find out the maximum number of students. So what we are actually trying to find out is, n being a common factor, what is the maximum value it can take? How large can it get? The largest value that the common factor can take is what is going to be the answer to our question. The largest value the common factor can take is nothing but the HCF. So the answer to our question is actually nothing but the HCF of 147, 441, and 784. Once you've realized this, things are straight mechanics, right? Let's prime factorize these 3 numbers. 147 prime factorizes as 3 into 7 square. 441, 3 square into 7 square. And 784, 2 power 4 into 7 square. The only common prime is 7. In its lowest power is equal to 7 square. So the HCF of these 3 numbers is equal to 7 square. So the maximum number of students in this class is equal to 49. That's straightforward. See, the moment you plug things into some equation or you start listing things down, things fall in place. This is one part of the question. There's a second part to this question. Let's complete that too. How many more chocolates did each student get than the number of pencils he or she got? This leaves me with the fact that I need to find the number of pencils, and I also need to find the number of chocolates that each student got. See, let's say we realize that n is equal to 49. There are 49 students. We're going to create gift hampers. Each one will have a pen, will have some pens, X pens, will have pencils, Y of them, and it's going to have chocolates, which is going to be Z. Every hamper that we create will have X pens, Y pencils, and Z chocolates. And we are going to create 49 of each of these. How many pens do we have? We have 147 pens. We need to create 49 such gift hampers, each having X pens. So X is going to be equal to 147 by 49, which is equal to 3. Run through the same process for pencils. Y pencils, 441 divided by how many hampers do we have? 49 of them is going to be equal to 9. Z being the number of chocolates, we have 784 chocolates to be divided or broken into 49 hampers, which is going to be equal to 16. So each student has got 16 chocolates and each student got 9 pencils. So how many more chocolates? Each student has got 16 minus 9, 7 more chocolates than the number of pencils he or she got. See, this is one way of doing it. Let me just quickly recollect our prime factorization step. Pens 147, so 3 into 7 square. Pencils 441, 3 square into 7 square. And chocolate 784, 2 power 4 into 7 square. If this is n, then these numbers should be your x, y, and z. So 2 power 4 is the number of chocolates. 3 square is the number of pencils. We could have got the answer directly without doing any of these things. Check out the related videos and remember to subscribe to the channel. What's more, let's make scoring Q51 GMAT a reality. Sign up for the most comprehensive and affordable online GMAT Quant course at gmat.visaco.com. That's again gmat.visaco.com.